So now it's time for Chapter 8. Chapter 8 is a little bit of an odd chapter. We're leaving the realms of probability behind and we're making a step back into statistics. But before we can do that, we really need to think about how statistics will use the probabilities that we've discovered from Chapter 6 and 7, particularly Chapter 7. So let's think about this for an example. Suppose we have the building where I teach is full of classrooms, and every room is full of 30 people all taking the SATs. Random people. You can't, say, oh, I have a calculus class here and I don't know, an algebra class here or whatever. It's just random. Every student's everywhere, all genders, races, creeds, etc. Okay. So we happen to know from the SAT company that the mean is 1,000 for all people that take the test, right? And the standard deviation is 200, again, for everybody. So if we look at the individual people taking the test that day, I mean, if you have, a couple thousand people in the building taking this test, what's the shape? And what's the center? And what's the spread? Those three things describe the distribution for us. Okay, so let's talk about the shape for a second. We don't really know what it looks like unless SAT people tell us that it's normal or something like that. But at this point, they haven't told us anything like that. So we kind of don't know. It could kind of be skewed. It could be normal. Right, let me put it this way. Could be skewed, normal, uniform. I mean, we don't really know, etc. What's the center? Well, that we do know. We know what the average is because that's what center is. We know that the average is 1,000 because they told us so, right? If the average is 1,000 for everybody, then it's going to be 1,000 for the people that are in McDivitt taking it today. McDivitt being the hall where I work. All right, what about the spread? Well, we know that too because we know that according to the people that make the test, the standard deviation is 200. So the spread is then 200. Good. All right. Now, what about if instead of looking at individual people, instead of looking at random student to random student to random student, suppose instead I go into a room that has 30 people taking it, 30 random people taking it, and I don't get their individual scores. I take the room's average, and we'll call it X bar because it's a sample mean. Right? You have a sample of 30 taking the test, you take their mean. And then you go to the next room and you get their sample's mean. And then you go to the next room and get that sample mean, and so on. And now, instead of looking at individual people, I'm going to look at sample to sample to sample. What's the average from this sample? What's the average from this sample? What's the average from this sample? And I make a distribution of that. All right, let me give you a visual for how this is going to look. Hopefully when I paste, oops, hold on. Here it is. Okay, so this pink line right here, that's the distribution for individuals. It's kind of all over the place. It's wobbly. It's yucky, right? But when I look at sample means, if I look at X bars, then the shape becomes, as you can see from this picture, normal. Right? We don't know what it was to begin with, but when you look at the X bars, it's normal, right? And what's the center? Well, the center is the mean of all your X bars. So that's mu sub X bar, the mean of your means, right? You take one room sample mean, the next room sample mean, the next room sample mean, you add them all up and you divide by how many rooms there were. But wait a second, shouldn't your averages for your rooms be the average that it is for everybody, namely 1,000, right? Because if that's the average for everybody, then all the rooms should be about 1,000 for their average. But what about the spread? Now, if you didn't notice it, the green curve, the one for sample means, is much tighter packed than the pink curve. That's because it has a different average. It has sigma of the X bars, right? How much did the average vary from room to room to room? And there's a formula for that. It's sigma divided by the square root of n, which is 200 over the square root of 30 in this example, which according to Excel is about 36.5. Okay? Much smaller. It was 200 for individuals. It's only 36.5 when you're looking from room to room to room. Much tighter.